Thank you so much for introducing me and for having me. I just want to give a big shout out to all the people that organized this, because I feel like it's a very nice thing to be finally able to connect again face to face. Very, very briefly about me. My name is Justus. I'm a project manager and researcher at FIR at RWTH Aachen University. And what we are is a research institute and a consulting firm. So we are standing on two legs. And I am responsible in that institute for basically taking the value of data analytics and AI and transferring it into the economy. That's what I research about. Very quickly about this talk, about me and my expertise. As you see in the title, this talk is geared towards SMEs. So people who have experience in manufacturing, people who are hidden champions. If you are a tech startup sitting here or listening virtually, maybe you will not see like the most advanced technology here, or like I won't tell you anything new about algorithms, but I think I might give you also some insight into how SMEs think, how older companies think, and what questions they're currently asking themselves when it comes to data analytics. So, looking at the time, I have a very brief talk for you, and then we're going to do a bit of an interactive data analysis together. Let's see how that works. My talk has 3 points. Data analytics, why should I care? What even is that? And the third point is, how can I start? Let's jump into the first point. Data analytics, why should I care? Because data analytics right now is as ubiquitous for us as the air we breathe. Every time you interact as a consumer with one of these platforms, you are being analyzed, and you're also analytically using an algorithm that learned your past behavior. What am I saying with that? So if you are visiting a company website and there is a chatbot talking to you, that is analytics based. If you are using Netflix and some magic algorithm recommends you, okay, you might also like that series, that is also analytics based. And in the end, if you're ordering on Amazon and you're wondering how do they make it that within one day the product is at my doorstep, it's because they're using analytics for real-time delivery and for predicting what people like you might order and putting it already in the right logistics center. So that is all well and good, but when it comes to SMEs, that is not really applicable, because what these players are doing is a digital business model. When you are an SME, when you are producing something, you do not want to remodel your whole business structure, but you can still use data analytics. How is that? You can use every advanced technology like AI and data analytics basically on 4 different levels. You can go very big and go right there to the digital business model and create the next Netflix or WhatsApp and so on. But what you shouldn't miss is the 3 levels that are much more focused on the internals of your company. So you have the opportunity to create new business areas or to complement your existing business areas. Finally, you also have an inwards perspective, the internal optimization. So you can also use data analytics to improve the processes that you are already using. And to step out of theory for once here, I brought you 4 examples. What do I mean by that? So using analytics for marketing in a company, you could use AI algorithms to better understand your customers. This is something that you would normally do with your human workforce. AI can help support that. You can add an AI service, data analytics service, to your product. This is autonomous driving. Nobody is buying a Tesla because their manufacturing processes are better than Mercedes. They're not. They're buying a Tesla because of the value-added services that analytics provides, like autonomous driving. And you can crank that level and that perspective all the way up, of course, to fully digitalized business models like Netflix, like you just saw, or something very crazy where somebody who does satellite imagery is now using data analytics to analyze these photos and to sell an AI analysis of refineries and oil tankers via satellite imaging to banks, predicting the oil price in the next 2 weeks. So you might see that when on a satellite image you see that a certain ship is stuck in the Suez Canal, that oil prices are going to surge the next 2 weeks. So that is a very recent example. When we talk about German SMEs, right here where we're standing, what do they already use? What are the percentages? When you go into a company, what are you likely to encounter in analytics use cases? First of all, quality assurance in the production. You know this as AI-driven CCD monitoring, quality monitoring, and so on. Chatbots, not actually in the production, but facing the customer. Furthermore, self-learning robots, very interesting. Route optimization, and also a very famous example, predictive maintenance. So putting sensors on your machines and predicting when you will need to service said machine. Now I threw at least 3 different buzzwords at you. And these were data analytics. I also mixed AI in there, and I think I talked about machine learning. And what I always do at talks that are geared towards SMEs is also providing a little help about how are these buzzwords actually interconnected? Why is everybody using them synonymously? And we have made a small graphic. You don't need to fully understand this, but I will walk you through the 3 main steps. Why is everybody using this completely synonymously? And what I want to tell you today, if you pick up one theory thing, then it's that. Data analytics and artificial intelligence originate from very separate fields. They are very separate basic questions that you ask yourself. In data analytics, it's, I have this data set and how can I learn from it? I don't need to use AI to learn from a data set. I can use statistical models. Artificial intelligence is the question, how do I make an object think? Where it gets confusing is how these two are interconnected. Because you see, artificial intelligence recently bore a child in the 2010s, and it's called deep learning, which is basically called it's advanced machine learning. So machine learning is a sub-field of artificial intelligence. It's just a question of not how do I make objects intelligent, it's the sub-question of how do I make objects intelligent and learn? And this has been hugely appropriated by the guys from data analytics. This is used to basically provide business analytics. So they were like, okay, we don't only want our statistical models, we also want machine learning. Very nice, we'll take that. So this is kind of where this meshing together comes about. In the end, you could say, data analytics uses machine learning as a tool to provide better insights to businesses. There's also a small distinction between business analytics and data analytics, but I think you can already guess that. When I use data analytics for business, it's called business analytics. Easy as that. So now that we have like a quick overview of what you can do with that and what the term actually means, the question of SME is always very nice. Thank you so much for that, but how do I start? And the second lesson that I would like you to take away today, not about theory, but it's more an economical question, is do not use AI, 5G, data analytics, or all these technologies to build a technologically nice solution. Use them to solve a business problem. This is something that SMEs don't understand when they got caught into the hype of the marketing and so on. And this is something that I always preach when I'm doing consulting projects. If you do artificial intelligence because you want to say, I do artificial intelligence, you're going to wind up with a prototype that nobody uses. So One method, I think you all know, this is a startup convention here, so who am I kidding? It's a value proposition canvas. And this is only one of the methods that you can use. I just want to give one example of how you can actually create a data analytics case that means something. And that is by going into your company and doing an exercise like that. And you go to your employers and you say, okay, what are you doing? What are your pains? What is not working? And then on the other half, you can write down all the AI applications and data analytics applications that you can think of. So predictive maintenance, maybe, predictive quality, robotics, route optimization, anything else. And what you then do, and that is something that you might need a consultant for, or you're very adventurous yourself, is creating the fit between these two worlds. And AI and data analytics doesn't solve everything. The fit is going to be small. If you're lucky, you're going to get 3 use cases. But if you found these, I assure you that if you prioritize those, then you will get a use case that people will actually use, because you're making their life easier. You're solving their problem. Second thing that I always hear when I go to SMEs is we don't have data. That's wrong. There are plenty of data sources available, but you're likely in the fallacy that you didn't widen your horizon. So what you should do is start really thinking about, yes, I have internal data. Yes, I know how my machine works. Yes, my machine is spitting out data. But what you should also ask yourself is, can I use external data sources? So I have a model, I want to predict something. And that's something that we're going to do together today. So this is not just abracadabra, not just magic, where we use free, publicly available data that we just downloaded. It's going to be weather data. And we use that to improve our AI model for our business. And a data canvas, this is just one of the tools, again, that I present, can be one thing that helps you to structure, okay, what data sources do we have? How live are they? Are they internal? Are they external? And finally, this is a twofold message. First of all, if you're doing something very special within your producing company and it's out of your domain expertise, you're going to need support. So you're going to need either somebody like me from a research firm, or you're going to need somebody who does AI and analytics, one of the booths outside there with the vertical solutions. Approach them, talk with them about your problems and do something together. But it's never bad to know what problem you actually have. And so inform yourself a bit before. This is one information source. I got it from a study. I didn't think of it. These are thousands of experts who made a heat map and who were like, okay, if I have an application that I actually want to do, maybe you did the value proposition canvas and now you're all hot for quality control in your production, then look at the AI technologies that you need to use. So, for example, in quality control, you will likely need computer vision and machine learning. So maybe go to a provider of data analytics and say, okay, I already know that and that, and start talking their language, because your role as an SME in this economy is not to be a programmer. Your role is to be responsible and knowledgeable about the AI and data analytics use cases that you use. And this brings me to the last thing I want to do. There is technology out there to make the road for you easier. In the past, all analytics projects looked like this. So you go here, you have source data, you distribute it, you verify it, and then you do something together with a data scientist that's called feature selection, where you provide them with data, and the data scientist says, I can't use that, and you get really frustrated. And you run through the cycle, and after 6 months and 100,000 euros, you finally have a model that works. So this is the classic machine learning approach. And let me tell you, it is there for a reason. It is the classic approach because it works. And in special projects, you're still going to need to do that. So machine learning and data analytics is also project work. But AI and ML providers are getting to know their customers better, and they are starting to provide automated solutions. So for use cases that are a bit more standard. So maybe you don't have a very complicated machine where you need all the sensor data from. Maybe you just want to know what your customer is up to. Maybe you just need one small bit of quality control. There are platforms that help you horizontally integrate what you are trying to do with AI. Why should you do that? Because, in one word, platforms democratize machine learning. They make it more democratic. You will get more people on the table when you have a platform, a common platform that doesn't require 40,000 lines of Python, but that maybe has a visual coder. And you're going to get more support from the economic side when you can deploy your model into your infrastructure and you don't need to actually hire another guy who then writes an application out of the model that somebody else trained. So with this horizontal implementation that we're going to see today, we can kind of skip over a few steps of this process. Bear in mind, there's no solution for everything always. So you are going to have use cases where your platform is not going to give you that much of a yield. But in the end then, it also industrializes machine learning. So when you build a specific case on a platform, it will be easier to maintain, at least. So it's not like you wrote 6,000 lines of code and then somebody approaches it and first has to understand it. It's more about that somebody then sees what you built on the platform and can interchange and maintain that application. And I see I'm already diving very deep into theory. So I would say we just go into the second part of this deep dive workshop, and I want to keep it a workshop. I would like to not just this be a presentation, and I think we're going to analyze some data together. And right now, you are always, from this point on, can always raise your hand if you have a question, and maybe I will have some questions also for you. And we're just gonna look at a data set and see how we can analyze it and see how the platform that I'm using helps us. By the way, the platform that I'm using, I'm not getting paid by these guys. I just picked one that works. There are a million other providers out there, so just disclaimer, no sponsorship. What do we want to do together? We have a startup. I chose this for this convention. Normally we are an SME, but we want to do bike sharing. And bike sharing is basically a logistics operation. You want to have enough bikes at every station fully loaded for your customers. You don't want to put too many bikes there because that means you're wasted money maintaining them. So what we need is an inkling of how many customers are we going to have next day. So how much do we want to redistribute? How many bikes do we have to charge? How many do we have to repair and so on? And what we are using to derive that is past data from just one thing. How many customers used our bikes at a given day? And we amp that up, and that's what I told you in the beginning about using external data with weather data. So we are going to use the weather report of the next day to predict how many people are going to bike. Why does that work? Because I made the assumption if it's very, very cold and raining, we are going to have less people using a bike. So let me just fire up the platform. And we're going to get started. Yeah. So this is a cloud platform. I see some people already know this one. What is that? A cloud platform is a machine learning platform that also provides you with the capability to do everything in a browser. And that becomes really useful in 5 minutes. You're going to see why. So what I want to do here a bit is show you that machine learning and AI is not necessarily somebody sitting in a dark corner and writing 60,000 lines of Python code. It's something interactive that you can do with people who know something about business and about manufacturing and not about informatics. So we first pick our data set. It's an Excel, and there's nothing wrong with that. And the first thing we have to do is understand our data. And What we have here is a lot of columns and a lot of rows. And every row is one day where somebody used our bikes. And also one day where we had a weather report. And in the final column, we have something that we want to predict with our model. We have the number of users. And what do we want to do? So the platform asks us, do we want to find patterns in our data? Do we want to build a predictive model, or do we want a time series model? I can spoil you already that we want a new predictive model. The other things are also interesting. The first thing, finding patterns in your data, is so-called unsupervised learning. That's you throwing data at an algorithm when you don't even know what you want to do. So you can get some meaningful insights. We already know that we want to predict something. We want to predict the number of users. So we're going to build a new predictive model. And now we can choose the column that we want to predict. So this is the number of users. And then we can click next. And here, up here, you see our workflow that we're doing. That is the steps, the pipeline that I just showed you. But we're not having a data scientist sit next to us. We have a platform that tells us what to do. And one big thing that when you go into SMEs is a big problem is that they know what their data means, but they don't have the perspective of a data scientist, which data they shouldn't use for statistical reasons. Here we have something that is unticked. So we have something that's called laufende Nummer. So it's just the number of the data set, and we have a column that says IDness, and we have a red warning. So, first question, just raise your hand if you think you know what that means. Why was this deselected? Why shouldn't we use this part of the data? Okay, are you also willing to answer? Oh yeah, that's a very good answer. It has nothing to do with our prediction. Exactly. So we just put a running label on our data, 1, 2, 3, 4, 5, 6, 7. And it's even worse. It not only has nothing to do with our prediction, it actually skews our model. It screws it up. And I see the guys nodding already here. I think they've maybe made that mistake. And it's a very common mistake. And platforms can help you to find these errors. There's also other measures like stability, missing. Missing is very important for SMEs. You're not going to have a nice table where everything's in there. You're going to have a table where you have one column that is full and the other one has 50% of values missing. And this platform can help you. Okay, what do you want to do with the missing values? We just chuck them out. We fill zeros in there. I do a linear interpolation. This is normally stuff that you pay a data scientist a lot of money for to sit with you at a table and talk about. And again, this platform doesn't replace a data scientist, but in some easy use cases, it can help you build a prototype without one. Okay, so I'd suggest I stop talking. We go to the next one. And here we have the interactive part that I was looking forward to. We can select models. Normally also something that a data scientist does. So he is sitting there, and with his years of experience, he looks at your data and he thinks about the algorithms that he wants to use in your data. And we are all data scientists here right now, basically, after 20 minutes of me talking. So you're going to choose the models. And don't worry, you cannot break anything. So I would do this by show of hands. I think we're going to pick 3 models. Who wants a linear model? Who wants a linear regression? Okay, one person. Maybe we're going to pick that, but then I think I already know where this is going. Who wants a deep learning model that we train on this data? Okay, deep learning. We're going to do this. And now we have either a decision tree or a random forest or a support vector machine. So I want more shows of hands. Do you want to go the tree-based route, or do you want to go the support vector machine? And don't worry, I'm going to tell you what they do. So who's for trees? Trees sound nice, don't they? And support vector machine? Okay, all right. So I'm gonna leave your linear model and we're gonna do the support vector machine. Okay, so now one thing also very important for producing companies is at this point, you would normally have to use hardware to train this model. And this is not a very difficult model. We have 700 rows about, and we have about 15 columns, I think. So on this laptop, this would take a minute, maybe. But in manufacturing companies, you have data sets from machines, and it's super easy to have 600,000 rows. And your laptop is gonna crash every time you click the run button. It's gonna say, oh, I'm out of memory. And what these AI and data analytics providers understood is nobody wants to buy a custom computer to train AI models. If you want, you can do it in the cloud. So if I click on run, I'm actually not running this model. I'm communicating with a server that trains this model. And this is gonna help me out tremendously when I click on run analysis. So now I actually hope it goes fast and doesn't take too long. Right now we are training our model to predict the bike data set. Are there any questions so far? Please raise your hand. Otherwise, we can just talk about it later. All right, this is looking good. Okay, yes, please. Normally there should have been one person. I don't know if I'm too quick, but they should have given you a microphone. That's a very good question. I like that question. So when I was asking you, like, what model do you want to choose? How should you know? I made a joke about it. In the end, in the first step, you won't know. But the nice thing about this cloud platform is you can chuck 6 models at it, and now we're going to see which one was best. So my answer to that is try and error. Just do it. And this is what these platforms do. They teach you that data analytics doesn't hurt. You cannot go so wrong that somebody gets hurt. So just do it, try it out, and now we're going to compare those models. So what do we see? We have an error statistic here. Error is bad. The higher, the worse. So we have a deep learning model that did quite well. Our decision trees are very simple models, didn't do that well. And our support vector machine did very, very well. So even a bit better than deep learning. I can already spoil to you, this is a standard pre-trained deep learning model. So this is one size fits all. If you had a deep learning model that is custom tailored to this, it would blow everything out of the water. But what you can see very nicely here is that precision isn't everything. So what you already have here is a model building time. So you see, I will read those numbers to you. I know they're a bit tiny. It took on the cloud, we are running, we're running a lot of power here. On the cloud, the deep learning model took 1.5 seconds. The support vector machine took nearly 3 seconds. And the tree took 0.3 seconds. So this is 1 second of difference. And you're going to say, okay, that doesn't matter to me in my everyday life. If you have 600,000 rows, this becomes 1 hour and this becomes 2 days. And then you're going to think twice about what model you want to train. Because every time your data changes and you have to wait 2 days for the next model, there are people who are going to say, we're not employing that here. So this is also something very important here, no free lunch, okay? You gotta use the tool that is best for your application. So coming back to your question, when the person who sponsors your project says, I need something quick and dirty, it has always to be up to date, and I'm gonna need to be able to run it on small laptops. You're gonna ask them, is that precise enough for you? And if yes, you're gonna use that model. And if somebody says, I want precision, 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 you're going to take the slow one, the support vector machine, and you're going to say, at least you get some nice precision in there. So this is also how you should think as a project manager about your data analytics projects. You don't have to know exactly how a support vector machine works. You don't if you manage an AI project. But you should know that there are pros and cons to using different models. And that will actually help you talk with your data scientists when they approach you and they're like, I'm sorry, we can't use that model. You should listen to them, and then you can talk about alternatives. I want to revisit now one aspect. By the way, we have some more like comparison variables here. This is just an overview. So we have average absolute error and we have average relative error and so on. And if you want, you can go to Wikipedia and see what they mean, and then you're smarter. I always forget what they do because you can literally look that up. You have a squared correlation. This one is the higher, the better. And we have a model building time. This was how long does it take to build our model. And what I now want to talk about, basically the last aspect before I open up to questions, is this integration aspect that I talked about. Because normally, you could have done this maybe also in Python in the Jupyter notebook. You would be there. But what do you do then? You cannot just like always say, okay, if you want to know this stuff, then please use the Python notebook there. And your worker is going to be like, the what? And so what this also does is horizontal integration in the form of one-click deploy. So if you have a model that you like, so for example, we say, okay, we want the quick one, we want the decision tree. We can click on our value and we can see, okay, detailed statistics about this. So it tells us in natural language, even though it's just a bot, this model accomplished an average absolute error of 614. We're like, huh? And then it tells us what this means. It means if you predict the Anzahl user to be 4,300, it is very likely to at least be between 3,700 and 4,900. And you can be, that's great, because we have 0 to 7,000 bikes. So this thing already tells you which neighborhood you have to go in with your bikes. And if we like this model, we can click here on Apply Model and we can click on Deploy. And when we click on Deploy Model, we can get a URL. And this means that this platform hosted a web service with one click. I don't know if any of you know about web development, but normally that takes one guy a whole day to put all of this code, to pickle it, put it into a Docker, and then make it available, talking to a server. We just used one click. So maybe you cannot do a lot with that one right now, but if you have an app developer, he will kiss you. And in the end, what's also very cool is if somebody doesn't really believe you, you can also download this process, and what you can also do is simulate the model. So this is not really deployed right now, but we can start to use our model. So if you're having a presentation about why you should use data analytics for these bikes, you take this to the keynote and you say, okay, we have the support vector machine. And this will tell us, this will let us play with our model in real time. And this helps so much communicating to people what this actually does. So we see if we tweak our weather data here, then this has an effect on the prediction. So right now our model is saying, based on this input data that we are giving on the left side, we are getting a prediction there. So based on this data, you're going to have likely 5,000 bikes the next day. Again, there's lots of platforms that can do this, okay? So the thing that I want to give you here is also don't just view data analytics as coding. Look at it as a business solution. And we can also, this is what happened to me, we can also learn something new from our data. Because I just wanted to predict in this model, I just wanted to predict the number of bikes based on the weather. What this analysis also told me is that our business is growing. Why? Because I put the year in there because I have a date. So I put the year in there as an input, and we see the smaller we make the year, the less bikes we're going to get predicted. So in the end, if we scale this up, I think this is year 1 and year 2, and it has a weird scale here. I'm sorry, this the value it says is 4,000, but these are just years. You see that the later the year is, the more bikes we have. This is something that I didn't know before. So this is the second thing. If you have a model that answers your question, you are likely also going to find out something more about your data. And if you really want, we can share this simulator via a public link. And this is going to be hosted as a very, very simple front end. And I could send you this public link right now. This is going to load now because it hosts the web service, and you could play with that model in real time. I don't know right now how to give you the link, but this is also a very neat application of that. So, are there any questions? Because this was the interactive part of our data analysis. I think we have 3 minutes left. So if there are any burning questions, you can raise your hand right now and talk to me. If you have, okay, thank you so much.
I will hold it. Just speak.
Yeah.
No, do not.
Okay. So what about data preparation aspects and requirements for data to be loaded into your models?
Could you repeat that one more time?
Data preparation aspects? Like
yeah, data preparation, yeah. So, some of the data preparation, like you saw, you can do in there because it tells you what data to use and what not to use. And what I didn't show, because this is a very quick process here, it can also fill up your data. So these are two of the functionalities. And yes, this is not everything in data preparation that you have to do. So maybe you will have to use a bit burlier tool for that, not just a small web app. The same provider has an on-premise platform, and it has a functionality called Turbo Prep. And you can imagine this as, before that, we can put this in Turbo Prep, and there you have a lot more. So also this is covered by platforms, but not in this web platform, for example. Very important step, though.
Any other questions? Okay.
Yeah, okay. So.
Oh, hi. I was just wondering, how about data literacy and onboarding all employees within the company to use data? I'm not talking about data scientists or like, boosting them to make them data proficient, but to make them data literate.
Data literacy is a huge topic. It's something we're researching also on, and it's very important because, like I said, you do not have to make everybody a data scientist in your company, but people have to know what this data means. And I think this is 50% of the solution. This is the technology aspect. This democratizes because it visualizes. So you get a tangible, intuitive understanding of your data. The other 50% are purely organizational. So this is the company having to understand that I need to make time to teach my employees. So this is also a very important aspect. I think this is only half of the solution that I'm talking here. But this is exactly what I meant. You got to be a responsible AI user. Doesn't mean you can code. It means you know what your data is and what your models do. Thank you. If there are any further questions, because I think we are slowly running out of time, we have a booth. We are from FIR, like I said, so you can find us also in the booth section. You can talk to us. My name has been Justus Benning, and thank you so much for listening.
We have to thank you, Justus.